Okay, now we are at question 7. So question 7 is a bit different already. Now if you look at the range, right, you will see that the range we are looking at for x is within 0 to 0 and pi. So here you will do 0 to pi. Okay, so see, let's take a look at whether we need to find other range. Here you see sine x, cos x, and cos x. Meaning, the range I'm looking for is only for x. That's all. So before we start, right, once you see the range, right, it's better to change your calculator mode first. So just a quick one. Can you go into setup? 0 degree. You want to find for radian. So currently, we will be working with radian mode. Okay, now let's try to solve the question. So it looks a bit different, but it's exactly the same. Do remember that sine x will always be together. Cosine x is together. Okay, we cannot write cos. Cos doesn't have a value. So once we add this step, right, the first step is we always need to try to have, cos x equals to something or sine x equals to something. With this case, we can't do it. So what we'll do instead is we'll bring the cos x to the other side. So you'll get something like this. Now here you will see, I have sine x, cos x, I also have cos x. So what can I do next? I want to do zero product again. But in order to do zero product, I have to put it in the factorized form. So I can actually factorize the common term. Okay, so you see here you see a cos x, here you see a cos x. So let's factorize out cos x. So what are you left with? 2 sine x. So factorize means to say I divide. Cos x divided by cos x give you the value 1. That's all. So now do you see a zero product? Okay, so now here I can write it as cos x equals to 0 or 2 sine x minus 1 equals to 0. Let's do it quickly. I will get this thing here. Okay, is that all for my second step? My finding reference angle. Have I found it? I haven't found it yet, right? So what I need to do next is to find the reference angle. So in order to find reference angle, I'll write here reference angle is equals to. Okay, same thing here. I will do this. Okay, cosine inverse theta 0. Oh, I get a value that's very ugly. Oh, before I move on, do you remember the special angle we are working with previously? So we know that if I put it in angle mode, okay, this is a special kind of question. If I put in cosine example, now cosine inverse 0. You realize that the answer is a very nice, like 90 degree. Okay, 90 degree actually can be placed as a radian mode for more accurate values. 90 degree. Okay, do you remember pi is equals to how many degree? Okay, pi is 180 degree. Pi radian is 180 degree. So I have special angle like example. Pi over 2 will be 90 degree. Okay, so I want it to be most accurate form. So for that case, right, I cannot use the calculator in radian mode for this case because I have this special number. Okay, similarly, some special angle that I worked with before in the previous part. Do you remember 30 degree? What is 30 degree equals to for radian? Pi over 6. Another special angle, 45 degree. So what is this equals to? Pi over 4. Similarly, another special angle, 60 degree. It's just pi over 3. Okay, so there are cases that we might get this special value when you learn your special angle previously. So cosine inverse 0, if you what you see from here, is actually 90 degree. So I can write it as a special angle to be pi over 2 radian. Okay, that will be my reference angle. Similarly for this case, reference angle for sine inverse half. Okay, sorry, to keep it consistent, I write it as cosine inverse 0 is pi over 2. So similarly here, I will press sine inverse half. What's the value you see? 30 degrees. So since it's 30 degrees, it's actually pi over 6 radian. That's my reference angle. This part clear? Okay, this one will work very importantly for your special angle only. So later when we do other steps, you realize that it's not necessary. I have to put it into this form. Okay, so now the next one is ASTC. So similarly here, we do our ASTC. Okay, let's identify the quadrant. I want my cosine to be 0 degree, means to say is positive, or 0 radian, positive. It means to say which quadrant should it be? Same thing, quadrant 1 and 4. So quadrant 1 will be just the reference angle. Quadrant 4 will be 360. Oh, sorry. Now we are working with radian, right? So it should be 2 pi minus reference angle. Okay, same thing here, ASTC. Which quadrant will it be for the sign to be positive? Sign to be half right is a positive value. So first and second quadrant. So the first quadrant will just be the reference angle. The second quadrant will be pi minus the reference angle. Okay, 180 minus reference angle means 180 is pi. So with this information, I can just continue with this. So x is just equals to first and fourth quadrant. And first quadrant being just pi over 2. So the fourth quadrant is 2 pi minus the reference angle, right? If you want to use calculator, you can also press it this way. So you can just put, you treat pi like a fraction, like a algebra, x. So it's like saying 2x minus x over 2. It's like 2 minus half. So you usually use improper fraction. So you get 3 pi over 2. So you can write it as 3 pi over 2. Okay, is there more quadrant? Can I plus a 2 pi or minus a 2 pi? For this case, you realize if I add a 2 pi to pi over 2, I'll go over the range of 2 pi. If I subtract a 2 pi from pi over 2, I'll go below the range. I'll get a negative value. So for this case, we only work with one cycle. Okay, so similarly now we also have another one, x to be first quadrant and second quadrant. So our first quadrant, the answer is pi over 6. Second quadrant here, we need to take pi minus the reference angle. Pi is like saying that it's x minus x over 6. So we just take 1 minus 1 over 6. And you get 5 over 6, right? So it's actually 5 pi over 6. And similarly for this case, if I add a 2 pi or minus a 2 pi, another cycle or before or after, it will go out of the range. Therefore, the final answer for A, x is just pi over 2, pi over 6, okay, 3 pi over 2, and 5 pi over 6. And that's for your answer. Is this clear? Okay, now can you try question 8 on your own? Question 8, similarly, it also requires you to use the special angle. So we will still keep our calculator in degree mode. Okay, once you are done, you can refer to the next video.